Have you ever wondered how your smartphone can surf the web, run video games, edit photos, and execute thousands of other programs in the blink of an eye? The answer to that question would be that it's from a computer science major. There's a good reason that 9 out of 10 parents want their kids to study computer science, and that's because computer science is a broad field that grows exponentially every year. Tech companies in every state are in constant need of manpower to supply an ever-increasing amount of consumers. In this speech, I will inform you of the development models of software programming, a crucial component of computer science. So most people will think that computer science majors come out of their programs and they get a job where they clock in and out of an office every day and write lines of code for 8 hours, and they don't do anything else for the rest of their life. So this may be true for some programmers, but computer science majors have much more choices in their job fields than just coding all day. And one of those is a lifespan development model manager. So a lifespan development model is a specific plan that a company has in order to execute A, B, and C, you could say, for their specific project. So if you need to make sure that your project development is organized, you use a project development model that will help coordinate a team of programmers and managers. So the first project development model would be the code and fix model. So the code and fix model, in its name, entails just coding the very basics of a program. Like, say if I was making a video game, you would program how to go up, back, left, and right. So once you program that, you would start building upon that very core aspect of the program and then start detailing it and fixing errors basically as you see it. You're improvising as you go along in your project. So this is really good for maybe an individual or small company that's making a smaller website or portfolio, but for larger companies who need a lot of planning and development before the coding, this is not a good idea. So in order for these companies to use a model, they need to use more of a planning-based model, which brings you to a waterfall model. The waterfall model is based off of a graph that shows a ladder of steps that a company has to go through to complete their software and develop it completely. So a company will look at this step and say, okay, in this step of the development process, what do we need to have, what requirements do we need to meet? So at the beginning they write their requirements, and at the end of that specific step they'll say, did we meet these requirements? And if they didn't, they'll completely redo the step of their development process, and if they succeeded and did meet the requirements, then move on to the next step. So this is really good because it can create a smooth model with lots of documentation, and it helps to make the program a lot better, and if the program's better, consumers will like it more and it'll make the company a lot more money. However, if you run into a lot of errors in your software development process, this specific model will cause the company to spend way more time in the planning phase of their development rather than actually coding. And whenever maybe an investor or shareholder sees, wow, this latest product that our company's been going and developing has been in its planning phases for months and months and we're just wasting money, they're going to take out the money that they've been investing, and a project can completely be terminated just off of a few errors. So this has been the major flaw in the waterfall model, and in order to build upon that, people were saying, we need to find a model that still uses that conservative techniques of the waterfall model, but also has more of an efficient, faster way of developing a product. And that brings us to the spiral model. So the spiral model is a risk analysis based model that a company will use, and they'll in most cases they'll take the biggest problems first and work their way down, and they'll analyze the problem, the risks that they're predicting, and then they'll solve the risk, they'll study it, they'll try to find the most efficient, the best solution, and they'll just keep going in an endless cycle of risk analysis and risk solving until they've completely developed their product. This is really good because, as I said earlier, it's very efficient and it's a very fast way of developing software, because a company not only is solving its program's main risks before they actually occur, they're also developing the product and coding it as the risks are being solved. So as opposed to the waterfall model, they're actually coding their program while they're solving problems. And this is really good because, as I said, it's fast, but it's also kind of detrimental because sometimes the risk analysis can make companies a little bit too on edge about their risks on their programs, and they'll say, well, maybe this program's a little bit too innovative and too risky to invest in. Maybe it won't do very well in market. So they'll completely terminate a product just because it might be too risky. So overall, computer science is extremely important. It's mainly comprised of coding and mathematics, but the organizational aspects a computer science major comes in contact with every day is equally important to the success of his or her project. If they were to choose the code and fix model, their product may be functional but clunky and unreliable. Using a waterfall model is safe, but could send their product into a prolonged planning stage. And if they work within the spiral model, their product could either be finished extremely fast or completely terminated because of risk. Hearing all of this talk about development models and organization may bring you to believe that this is a speech about Wall Street, but in reality, this is a day in the life of a computer science major.